Hey kids, Mrs. Spence here, and it's time for another wonderful video on 8.6, Proportionality Theorems. I've got the assignment that you'll get next class here. You do not have to do that right now. We'll do that next time. And I've got just a few notes already written down on my sheet, so that I want you to go ahead and write these down. Pause the video, get all that written down, and then come back and I'll explain the proof to you. So pause the video now. Alright, hopefully you have that all done and all written there. This is called the triangle proportionality theorem. And what that means is a lot of words for basically just nested triangles. Alright, and what's super cool when you have nested triangles? It says that if a line parallel to one side of a triangle intersects the other two sides, then it divides the other two sides proportionally. And basically what that means is that this line is parallel to this one right here, then we've got similar triangles. And these sides are proportional. Now, before this theorem, we would set proportions up. This segment is equal to the entire segment. This segment, I'm sorry, it's not equal, they're proportional. This side right here is proportional to this entire side, and this side right here is proportional to this entire side. But what we're going to do today is prove that not only is it proportional to the entire side, but TR here is proportional over TQ is proportional to RU over SU. So just little pieces are proportional, which is weird because we're going to pull this triangle, just part of the triangle, out and not use the entire side there. So you can see here in the proof statement, RT, which is this line right here, over TQ, which is this little bitty line, is equal to RU over US. And that's just another theorem that you can use to set up proportions and solve them. So the first thing I have written here is the given. It says if a line is parallel to one side of a triangle, and so that's what's here. TU is parallel to QS, and that's given information. All right, we also have the picture marked up already that angle Q, is congruent to angle RTU. And you can see that those have already been marked in the picture, so we need to write that in our theorem. Angle Q is congruent to angle RTU. And that is, obviously, if parallel lines, then we have corresponding angles congruent. So we're going to put corresponding angles congruent. And then remember, that only happens if the lines are parallel. In addition, we have angle S is congruent to angle RUT. So angle S is congruent to angle RUT. Same exact reason. Corresponding angles are congruent. Alright, so the next step down is we basically can say that the triangles are similar now. So triangle RQS is similar to triangle RTU. When we write this similarity statement right here, we can do so because notice we have angle, 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 angle. We have the angle, angle similarity postulate. So we know the two triangles are congruent. Now, since the triangles, we know the two triangles are similar, not congruent. So since the triangles are similar, then we know that RQ over RT is equal to RS over RU. RQ over RT is equal to RS over RU. And that's just definition of similar triangles. Alright, that's what happens when you have similar triangles. So step 6 is that if we take TR and we add that to TQ. So TR, and we add that to TQ. See if I can write that under here. TR plus TQ, and we put that over RT. I'm going to have to use 2 lines to get this in here. That should be equal to UR plus US over RU. And that's basically just the segment addition postulate right there. Segment addition postulate. Alright? The fact that we can take and we can add this segment plus this segment to get the entire segment. Now, look at what we just did here. RQ, this entire line right here, is TR plus TQ. So we just took that RQ out and we put in the segment plus the segment. And the same thing on the RS side. We took it out and put in RU plus US. Alright, so if we simplify this, we get, I want you to try to remember this, it probably would be easier if I just explained it this way. RU, if we took TR plus TQ, and we simplified that a little bit, and then we took RT and multiplied that UR plus US. Let's multiply that out. Now keep in mind that